Okay, so our first demonstration will be for evaporation, and the smiley face on the left will be evaporating at room temperature. Smiley face on the right, I'm going to use this hair dryer, and we're going to see if the heat and air from the hair dryer can speed up the evaporation. So here we go. All right, we'll conclude our test there. You can see the mouth is almost gone and the right eye is almost gone. So why do you think the heat caused the water to evaporate faster? The answer is because heat provides energy to the water molecules. It causes them to speed up in their movement. It causes them to begin to spread out, and they're able to leave the liquid state and turn into their gaseous state. And molecules in a gas state are more energized and they are more spread out, able to fill the room. So heat provides that energy, allowing them to become a gas much, much faster. Okay, for the next part of our demonstration, I have ice and water in an about a little over 500 milliliters of water. And I just put it in here, so we're gonna wait and see if we can notice any signs of condensation. Okay, so I'm gonna pause it and then I'll play it when I notice some condensation. All right, we see some condensation here, and actually the longer we wait, the more the condensation will start to build up, and you'll see the droplets start growing in size. Okay, and when I wipe my finger against the outside of the beaker, you can see it clears it up, and it leaves some streaks of water. But if we wait long enough, you'll see that it will just fog back up again with the condensation droplets. Okay, and what you're seeing here is the water vapor in the air of this office is clinging to or sticking to the side of this beaker. And it's doing that because, remember, cool air holds less water vapor than warm air. So the warm air around this office has water vapor, and when it comes into contact with this cool surface, it cools the air that's right around this beaker. And that cool air close to this beaker, the water vapor is squeezed out and it clings to the surface or sticks to the surface of this beaker. So when that air is cooled, the water vapor has to go somewhere, so it attaches itself to surfaces. And that's how clouds are made. Okay, in the atmosphere you have dust particles from smoke, even maybe some pollutants. And when warm air rises, the higher it goes in the atmosphere, the cooler it gets. And that warm air that's saturated with water vapor will cool, and the water vapor will start clinging to dust particles in the air. And eventually the droplets will keep growing in size, And when they get so big that they cannot stay in the air anymore, gravity will take them down, and that's how we get precipitation, like rain, snow, sleet, and hail. So condensation right here. Now let's see if we can observe precipitation. Okay, so here's our precipitation station. We have a beaker filled with about 450 milliliters of water. I did put food coloring in this water to give it a blue color. And it's currently heating. And I'm going to pause it and wait till it's brought to a boil. When it's boiling, I will put this pan on top of it. But inside the pan, I will put some of this ice water. And we're going to see if we can cause some rain, some precipitation. So let's wait and see what happens. Okay, we're starting to get a few bubbles that float to the surface. If you look really closely at the bottom of this beaker, you can see the convection currents moving through the water. That water movement you see there at the bottom, that's the hottest water, and it's mixing with the rest of the water. So you're actually seeing convection currents, and that's caused by different densities of the water, by the water heating. So pretty cool. Okay, so we're getting a boil now. And those bubbles that you see, that's actual water vapor. That's water in its gaseous state. So the boiling point of water is 100 degrees Celsius. And when water reaches that temperature, it begins to rapidly turn from liquid to gas. Okay, and you can see the water vapor leaving and escaping into the air in its gaseous state. Okay, so we're going to go ahead and pour this in. Now we know from this condensation demonstration that this is a cool surface, so when that hot water vapor, the air touches this cold surface, it should cause very, very rapid condensation. And you can see a cloud forming. Okay, and clouds look really white and fluffy from the ground because that's the sun reflecting off of the water vapor in them. But if you go inside a cloud, it's actually very foggy, and it looks a lot like what you see here. Okay, so this water vapor is beginning to condense on the cooler sides of the glass, and it's also condensing on the cool underside of the pan very rapidly. You can see the droplets are growing in size. So there's our first raindrop. So not only are the drops growing in size on the sides of the beaker, but they're growing very rapidly on the cool underside of that pan. So we have evaporation, we have condensation, and we have precipitation. Let's see if we can get a better view of the underside. If you keep waiting, you'll actually see some drops. It's hard to see behind all of the drops on the sides of the glass. But this is a very basic, simple model of the water cycle. What do you think the hot plate represents? What gives the water cycle its energy? What heats the water? That would be the sun. Okay, and the blue water represents bodies of water in the water cycle. And then the pan represents the cool atmosphere. As warm air rises, it cools, creating condensation, and eventually precipitation falls back down to the bodies of water. Now, of course, we do not need to have boiling water for this to happen. It just speeds it up and makes it something we can observe in just a few minutes and in a very small model like this. All right. So I'm going to send you some questions and you can answer those questions using this model. And if you have your notes in CK12, you can use those as well.